Hello, everyone. Welcome back to another episode of the Net.lol podcast. I'd like to, first of all, welcome my co-hosts, Dave and Tom. And I'll note that we're missing Brent this week, but we also wanted to say congrats to Brent and Leslie on the birth of their new baby boy. So Brent's probably home doing things that are much more important than podcasting. So congratulations.
Congrats, everybody. Yes.
Yeah. And we're very excited to have Vinny Parla back on the show today. I think this is Vinny's third time on the show. He's going to lap everybody a few times in terms of our guests.
We're going to have like a jacket for the, multi-guest club, you know.
That's right. We're going to have to get him some swag of some sort here soon.
We are working on T-shirts. They'll be here soon. So
yeah,
but at least we'll have that.
I feel like as long as the industry continues with, all of these cybersecurity issues, Vinny's going to be a frequent guest on the show because
we're going to have to talk a lot.
So Vinny,
I may have to be a permanent member at this rate.
Think so.
I think so, yeah, because it feels like every few days there's a new issue out there that we just end up having to talk about. So Vinny, how are things going? What are we going to talk about today?
So today I wanted to talk about a concept. It actually came from the military, DoD. I think Lynn was one of the first people to talk about it. And
Al, just so people know, Al works. He's at Cisco now, but he did run DISA right before that.
Yes. Yeah. And the concept is what they call left of boom. So essentially, when the IEDs exploded, it's too late, right? You've already done the damage. Sure, you can, help out the injured and do things like that, but whatever damage is done, right? And this is the problem in cybersecurity, right? Everything in cybersecurity is after the boom, right? It's to the right of boom. So after something has happened, for example, when a CVE is published, that's long after the exploit was actually being taken advantage of, right? That's when it essentially was communicated with people, investigated. So someone was the victim there, right? There was patient zero. And so a 0 day is before the CVE is published, right? Everyone's scrambling to patch Log4j. Log4j existed since 2013 and was probably exploited by at least some nation state for many years before it was actually widely known, right? And so the whole problem in the cybersecurity space is very little is being done to address the problem before it's detonated. So that's sort of what I wanted to talk to today.
So really what we're talking about is a lot of the things we've already discussed on the show and what people hear about is right of boom. That's what the industry has been focusing on, right? Is after something happens, how do we clean up the mess or that sort of thing? And left of boom really is this kind of proactive defense of trying to do what you can to mitigate that risk before something bad happens. So Vinny, would you say left of boom, it really is almost like a risk mitigation strategy to some extent too?
Yeah, absolutely. It's a combination of risk mitigation, but also active defenses that if here's Lynn now.
There's Al. Hey, thanks for joining.
Al, thanks for joining. So we were just talking.
You want to introduce Al?
Al, we are live right now, so
we're recording.
We jumped right in.
Can you hear me okay?
We can hear you. We
sir.
just brought you up, in fact. Vinny and I were just talking about you, so welcome to the show.
Hey, thanks for having me.
Yeah, so Al, maybe you can give a brief sort of history of left of boom and how you sort of coined that term or discussed that term, in your prior life, and we can just sort of pivot into the whole discussion around that. I was explaining, sort of in my very naive terms, but it'd be better to hear, your background on that. We could.
Yeah, so in my previous life, prior to working here in Cisco, I was in the U.S. military in the Department of Defense, and one of my last jobs was the commander of the Joint Force Headquarters Department of Defense Information Networks, which is a long way of saying I was responsible for cyber protection for the Department of Defense, Army, Navy, Air Force, Marine Corps, and the White House. So in that capacity, you're actually maneuvering cyber forces against an adversary. And in the military, you see the cyber domain no different than the air, sea, land battles. It's just another domain. And so you actually maneuver cyber protection forces to combat these very large attacks, and you're actually maneuvering to defeat the enemy as we looked at it. And a lot of the tooling that's out there in point solutions are set up such that you find that the enemy is already there. You find that the attack has already happened. So it's more of a history lesson. And what I was striving to do when I had that job was get to the left of boom. Boom being that point when they've already got access. They've already got something that's attached to your network in some way as part of a build towards a future attack if the attack was not underway at that time. So getting left of boom is really what you want to do. You want to see the attack when it's happening, see what they're trying to do at the time, so that you can take action and actually stop a cyber attack.
So Al, right before you joined, we were talking with Vinny about this too, and a lot of it is risk mitigation to some extent as well, right? Trying to keep things to that left of boom to handle the risk and try to mitigate that. Would you characterize it that way?
So I think overall you have to have a risk framework that you're working from, and you have to know, part of the issue with a cyber attack really has to do from the start. How did you design the network? So the network design is critical to what your field of battle, if you will, looks like. So if you didn't design it right, you've left holes open for, an attack to happen. And so you start with the design. And so from that design, you can then determine what your level of risk is. And then from that, you can design kind of a risk matrix of where am I most vulnerable, and now what do I do about it, right? So the risk mitigation, the whole risk framework is a must-have, but it's part of a larger look at what it is you're dealing with. So you have to understand the lay of the land, if you will, before you ever start trying to figure out how do I better defend the areas that are weaker than others, right?
The other thing I found interesting is that a lot of the problems that we're looking at today, Al was looking at 10 years ago. He had to really be on that literal bleeding edge of cybersecurity because he's, protecting the country, right? That's what his charter was. And so a lot of ideas, I'll bounce things off of Al, and he's like, yeah, we did that 10 years ago. Problems moved from that, and here's where really the problem is today, which is really interesting because it's, as I said, if you look at just like the Apple patches that came out recently, there was a scramble to patch a bunch of, Apple devices, one of the more secure devices out there, right? It's pretty well designed. But those vulnerabilities were right of boom, right? They had already been detonated, were already actively in the wild, and there really was no mitigations happening before those exploits were being taken advantage of.
Yeah, it's kind of, we were talking about this the last time. I mean, it's kind of a call to action here. I mean, there are CVEs that have been sitting around like the Log4j one for years, 5 years or more, right? So even before you get to the left of boom part, there's a lot of cleanup right now of the booming parts, right? I mean, there's a lot of documented CVEs. We need to go through those and mitigate them now, right? But you're right. I mean, you gotta get out ahead of the next ones too, right?
Well, and I think the other problem is, you know, how are enterprise organizations or smaller organizations, how does the left of boom thinking work with them? Because Al, like you were saying and Vinny said, when you were with the government, I mean, you had a pretty important role in protecting things. So, it's great to hear all the awesome things you're doing and you're ahead of everybody and that. But how do we kind of bring this level of thinking just to the average enterprise user in that, or is that possible, or like Tom said, are we just going to be stuck with kind of CVE mitigation and just understanding those?
Yeah, so I mean, I struggle with some of the, what we've built for ourselves. We are going to have this repeatable CVE environment, I think, for some time, unless we change what we're doing. It's kind of that, if you continue to do the same thing and you get the same results, you shouldn't be surprised, right? We're
Yeah.
doing the same things, so we need a change, I believe.
We talked about this last time, like how we build open source software, for example, is
well, you can talk about the whole SBOM, the software bill of materials, and what is it, what's really in there, and how much of that is really secure, and have we done a good job of making sure we've shorn up that piece where we've looked at all the pieces that make up the bigger whole for software, and where are the holes in that? I mean, that's another good place to look. But in my mind's eye, I mean, even from the beginning, the internet was not built with personal responsibility in mind. In other words, you don't have to have a very strong identity to get on the network and ride. And now this network that wasn't designed to run commerce is now running commerce. So it's really important. But we don't put the import that we would even on a driver's license. You have to have a driver's license to drive a car. You don't have to have any kind of a license to ride on the internet, which is our commerce now. So I think one of the starting points, if I was to really go after this, was and have tried, is identity. I think if we get identity and we can assess who's doing what on the network, then we can kind of help clean up a lot of the problems that we have. I mean, that's just a start point from my point of view.
Yeah, it's an interesting way to reflect on the thing, because the internet, the way the internet has progressed is actually very similar to conversations about how software is constructed now, in the sense that the stuff is not designed with security in mind on day zero, and so it's always addressed later, and in anywhere between baling wire and bubble gum, and mildly sufficient. And that's been the problem, right? Is that we go back and we do this stuff after the fact. Like Kyle and I have been working on starting a new community around another project right now, and the conversations we're having just right now and the genesis of this project do not have security in the conversations. First and forefront, on the forefront of the conversation. So, do we need an attitude change here too, or something like that?
I just feel, Tom, if it's like building software is like building a wall, right? You built this wall, and then somebody's like, aha, I can jump over that. Crap. All right, I'll put some spikes on top of the wall. That'll stop people from jumping over it. And then they're like, aha, but now we can tunnel underneath it. And you're like, oh, okay, I'll put some concrete under here. And they're like, but we've got a drill that can bore through that, so we can still tunnel under it. And you're just constantly playing whack-a-mole, right?
Yeah, it's
You
like cat
don't
and
want to
mouse
do
after
that. You
the
just want to
fact.
build the thing. Like you want to build the cool logging framework. You don't want to sit there just playing whack-a-mole the whole time.
Yeah.
And that's the problem, right?
But
There's
this is
far
the point
more
I've been
resources
making is that
poking holes.
security is like some of the other things that are in a lot of the projects and products, frankly, that a lot of us have worked on, where the cool stuff is what you were talking about. And that's what everybody gravitates towards working on. And, you know, doing stuff like mitigating a CVE, for example, is looked on as kind of a slog for a lot of people. You know, it's
But again,
that's not the fun stuff to do, but
but the CVE is too late, right? We have to get it out of the mindset of just patching, because patching's after the fact. And you know,
that's what I say. Like the MO, like maybe we're calling these things the wrong things, right?
yeah.
The spirit is the wrong one. It's patching, right?
I think
And
fundamentally it goes back to what Dave said, right? Too, because how many times, especially, I mean, whether it's open source development or closed source development, how many times is security treated as a feature or it's layered on top? There's a security group that'll take care
Not
of
intrinsic.
that. I don't have to worry about that. There's a security group. And I think that's part of the problem fundamentally is many developers just treat it as, that's some other group's problem, right?
And often in product creation, that's a priority call, right? Compared to other features, right, that you can directly monetize or something, right?
Well, think about it this way. If you built a car and it was badly built, there's all kinds of systems that will alert you to don't buy that car because there's all kinds of flaws in that car and you just wouldn't buy it. But we don't have a similar thing for software that I know of where it says, hey, this is badly built code. It's got a lot of CVEs, and so there's a rating for it, and you go to that rating site and you go, oh, why do I have this on my network, right?
Yeah, it's like a crash test rating. I mean, rewind back to the 70s, no seatbelts in cars. Oh, we didn't think of that. Let's do that after.
I think Al just suggested we need like car and driver for the software.
Car and driver
motor
for
trend.
security.
I love
right?
it. I love it. But I agree. I think you're right, Al. There really isn't.
But yeah.
There is nothing that rates it that way or that it does that sort of analysis to suggest that, okay, maybe it has features X, Y, and Z, but the baggage in terms of CVEs and how many updates they roll out and how bad the updates are and how they, there's nothing that really rates that. It's an interesting point.
But there's a way to do that. So there's the MITRE attack matrix. I think you all have probably seen that. It's a nice design. It's something very similar to what I was used to using in the Department of Defense. We had a framework very very similar to that, and I think that's something that we worked on, and we wanted the rest of the world to see that attack matrix thinking, where you take all of your security systems that you have, and you match them against that MITRE attack framework, and you can see pretty vividly where your gaps are in your most likely point solutions, because you don't have anything that addresses that full range of from the beginning of the attack through the middle of the attack to the end of the attack. That full range of an attack where your software defends in those spaces. That's a really good place to at least start this conversation about how good are we, what are our gaps, how did we build this, so we can really take a look at what our vulnerabilities are, and we can start talking about what our risks are.
So that's I was thinking about this the other day, like, we need to add the security phase to be an intrinsic part of the software development process today. Today, for example, the agile process that everybody uses, you have sprints and sprint reviews and yada, yada, yada. Those are typically either focused on, functional changes to the thing that you're building, or you're in the last throes of releasing the thing and generating the artifacts and building the thing. But during that process, there isn't an explicit phase like you were just describing, Al, where like, hey, there's this framework. Has anybody looked at if we're okay here.
Right.
And maybe not just if we're okay here at this checkpoint, but part of this continuous CI/CD process to continue to go do that, because somebody can undo things. How many times have people recreated a bug by fixing another one? That's never happened. But it's got to be the process has to be steeped in this for it to work. Otherwise, it's a bolt-on again, right?
Well, I'm jaded by my experience, but I think it should be sec dev ops. So the security should.
Yeah, exactly.
Well,
And
okay,
it's
so
something I've seen practiced, and it works. Like it's great having security people there to consult throughout the entire design of something, and then to help with some of the more functional bits of security as you go along. It's a great way of working.
But also,
But
that's still in the wrong vein of the attitude. It's still somebody else's problem. There's another group. What I want to do is make it everyone's problem.
well, I think
Like
the
everyone
problem
must
with
be
that is
learning
that
from these so-called security experts. Everyone needs to become.
Yeah. I think that's a great
right.
point, Tom, because I only ask one interview question now, and it's essentially the Python bug, which is I asked someone to tell me how big of a buffer you need to print out a float, and invariably you get really bad answers to that, and the answer is it depends on what the value is inside the float. Obviously, the smaller that fraction is, the bigger the buffer needs to be to hold the printed value, right? And once you get people into that thinking set and that mindset, they're like, oh yeah, like this stuff is way more different than just very simple, handling of buffers. I have to really think about like size of buffers, what are the risks.
And that's what I was saying. Like suddenly it's my problem, not. Yeah.
Well, in some ways, though, I find that part of the problem is all of these great levels of indirection that we have. Like, it's very easy to work in a higher level programming language and then just assume that, like, the language knows. Like,
Again, it's somebody else's
I don't
problem.
even need to think about memory management. Like, there's a garbage collector, and I can use memory. Like,
But that's
who
the
cares?
danger
Like,
too, is that yes, on the one hand, it's all consistently clean, but on the other hand, it could all suddenly become consistently dirty if there's an
Right, but
intrinsic flaw in the whole thing, right?
Right, but this is how Log4j came into being, right?
Right.
JNDI is a core feature of Java, and it exposed a capability that manifested itself in the Log4j bug. The Log4j bug's a great study, by the way, because everyone is dealing with the Log4j bug thinking that's the end of it, and they're not understanding that Java
there's more to it.
JNDI, Java's framework is the bug. So there's 100 other Log4j exploits out there that people just haven't realized yet, right? Log4j is just an easy button. But it does go to the mindset that, oh, well, it's someone else's problem to build this really cool programming framework, and I don't have to think about how it can be abused, which is the wrong attitude and mentality, right?
yeah. Although,
But I think most of these things added, though, are well-intentioned. Like, JNDI wasn't designed as, well, not as far as I know anyway, as a nefarious way of the runtime being exploited. It was like, oh, we need this cool feature for the framework for this thing that we want to enable, and this sounds like a really cool way of doing it. Terribly insecure, but like nobody realized that until later. And that sucks, right? But I guess
that's the right of boom, left of boom problem. You just said it right there. Nobody realized it until later, until after it detonated.
Well, everybody has to realize that it's there now.
The problem that I'm grappling with, like in my head, is like unless you have full visibility, like complete throughout the stack through to like what's touching the hardware and understanding that entire thing in depth, like you don't really necessarily know. And
that's a great point, Dave. I mean, I was thinking about this too the other day about the size of the projects that we work on. They get to the point where no single human being can understand what you just said. Is there a single person anywhere that understands Kubernetes today?
Well, that's kind of my point, is that if you think about it, like, I don't know, let's say you need a message bus And let's say we have this cool scoring matrix for message buses, and all of them are terrible. Like all of them have CVEs. So what do? Do you write a new message bus yourself and then keep hold of that, and that's mine? And that's my commercial property, and I'm not going to share it with anybody because then people could see what
Oh, but
exploits
that's
are there
also
and just
another
keep it
vulnerability
internalized.
too. People will go pick and choose things off the shelf and go, ah, my problem solved. I found another message bus. But they haven't figured out, like, if I snap this thing into this new framework, have I just opened up Pandora's box or something? Like, nobody thinks of that. They
I
just
think
go,
it
oh,
gets,
it's important.
and
It
it
works.
and it
Next.
gets even worse. This gets even worse, and this problem goes outside of security because what Dave brings up is the fact that many developers writing an application that's going to run inside of a container, orchestrated by Kubernetes, inside of a VM, on an operating system, on some hardware that's, let's say, on a Cisco VIC and is going to get switched inside of the Nexus 5K up to the top of rack. They couldn't begin to tell you how the data gets from outside of that fabric all the way up the stack to their application. And so if they can't even tell you that, then they have no chance at security for that stack. And it is true. Dave brings up a good point that this is all incredibly complicated, and in many ways we've done this to ourselves. But hey, if it's not cloud native, then I don't know. I guess it's not real.
Hey, Al. So, Al, how did you deal with this problem? Because you had the exact same problem of just the massiveness and the depth of stacks that you had to deal with. But you had a program in place to handle all of these sort of areas. What was the strategy?
Yeah. So, first of all, it's to talk about the extent of the problem. There's a whole R&D motion that is an industry where they have to make whatever it is they have better. So there's this drive also to keep changing things, just keep adding, keep changing. So the way I dealt with it is I created a security stack. It was called the JRSS, it's Joint Regional Security Stack. And what I did was I took best of class products that were available commercially and worked with the vendors to create a multi-tenant environment. So the point solutions that are mostly for sale, imagine me working with different vendors to create places within that matrix of attack where I could start plugging in solutions on top of it. So multiple solutions on top of that, so that I could again start closing those attack vectors, those areas within the network build that I knew I had a potential for vulnerability, and through that I was decreasing my attack surface, which is really, really important. And started thinking about not zero trust, which is kind of the current vogue, but how do I create a trusted network? So thinking differently about how my network was built was really important to me. So I knew I had to fix the current problem by reducing my attack surface, by creating places to capture the attacks that were coming in or to find them quickly. But then it was the next move was towards a secure network, a trusted network.
Yeah, and that's a good example of how you take the framework and apply it, to a software stack. Maybe, I mean, the questions that you are asking just now, those questions alone, what's the attack surface? How vulnerable do I think this product is off the shelf? I mean, just these questions are questions that are rarely asked at release time for products. And it's really, if people start asking those questions, they may go, wait a minute, maybe we should take a couple more weeks before we release this and figure out what the answers to those questions are. Because what ends up happening is then we get to the right of boom situation where it goes out and now we go, oh, wait, it's got a bunch of things. Wait, bring that back and patch it. And patching it turns into a bubblegum and baling wire exercise at some point where it gets so wrought with these patches and things that then you get a major revision. You got to kind of sweep it clean, and now we're back to it again. But
Well, you're right.
you
We are working on we work on different things in innovation. That's what I do, where I build new cool things. But we were doing a study on how long it takes. Where does boom happen? And it's averages over 200 days. So imagine waiting 200 days to find out you got a problem. That's a
yeah,
problem. That's a problem. So
yeah.
you got to
No,
get
so to
left of
frame
that.
that for people listening, right?
Even a
Kubernetes
boom, though,
release.
even a boom is it's a long stretch before you ever know that there was a problem. I mean,
Yeah,
200 days, over 200 days. Think about that. You've had a problem, something's been in your network. You've had this problem for over 200
cooking
days,
away for three
cooking
quarters of a year.
right there for you, and you never knew about it. So that's what's happening on the commercial side. That's that world.
Well, also without the analysis, think of all the other things that are getting created in the next release of the thing that are going to be there for the next 200 days and the next 200, and it's the cumulative addition that is the problem too. Like
So
the
we have to
patch
really,
mechanism says, well,
yeah.
I'm going to fix this little thing, but I opened port number 55 open or whatever for somebody to come in and have fun by accident.
Yeah, exactly right. So how do we get to the left of boom? And that's where we're spending a lot of our cycles trying to figure out how do we build things that get to the left of boom.
And that's a lot of the stuff you're doing now in the innovation group, right? That's sort of a big part of your focus is
Hmm.
getting security to the left of boom uh, as a strategy. That be how you describe it, Al?
Absolutely.
Well,
Absolutely. We got
I
to
want
get
to
there.
bring something else up that I want to flip this whole discussion we've just had a bit on its head, right? And what I want to talk about is the recent Lapsus hacks. And specifically, so everything we've talked about is great, and I agree, left of boom, we've got to do all of this. But then you look at what the Lapsus group did, and they didn't really take advantage of CVEs and things like that. They did good old-fashioned social engineering and phishing, and that's how they were able to be effective. And recruiting insiders, which is a whole different game, right? And so, Al, how do these types of things, which are perhaps less technical and more social, how do those types of things fit into this left of boom? I mean, do you have to factor these types of things in as well? Whether it's insiders or phishing attempts and these types of things.
Yeah, well, I think phishing attempts gets back to that identity situation where, if you have a good identity system, you know that this person coming in isn't part of your world, right? This person's not a real person. There's a lot of information available about who's using equipment, who's using systems, and it's all available. If we were just to aggregate all that information, you would know, A, this is a hacker, or B, this is not part of my community, not part of my environment. So block it, right? It shouldn't happen. So that identity piece takes a lot of that. Now, insider is a whole different bag. That's something where, unfortunately, if there's someone trying to be a nefarious actor, if they're inside your network and they have proper identity, proper credentials, it's a little bit more difficult. But there's a way of doing that as well that really has to do with, what's normal for you. So
Right.
part of that identity system, if you were to do it right, would be what's normal for Al. What in my day-to-day work, what would be normal for me? What would be my normal battle rhythm, if you will? What is my
Yeah.
cadence? What do I do? How many
Would you
emails?
be sending 1,000 emails to random people?
Yeah, if I'm sending 1,000 emails or I'm uploading, gigabits worth of information, red flags should be going off, right? That really has to do with what is normal. So syncing that kind of a curve, if you will, for what's normal for each individual is not that. I mean, it's not technically that hard to do. You can do that, and you can do it in a way that it doesn't identify anybody until there's a red flag. right? So it could be privacy preserving, but there's, at least in a corporate world, I think that would be the two things I would think of when thinking about those two issues.
One other thing I do is, and I've been doing this since I was at BT, trying to get this through, is don't trust your network so much. Don't assume so much. There are a lot of, and this is just, Kyle was talking about this too, like how smaller enterprises that don't have a massive team with people and all that, they have this naive assumption that their network is their network, and we went to a different model at different places since the BT thing, where we said, we don't trust anything. You must authenticate with everything, right? It's we call it the inside out model, but just because you're on the network doesn't mean you have privileges to access everything in town. That's another thing, like that people could do, is just trust a little less.
Oh, yeah, I agree with you 100%. You have to assume your network is hacked.
Yeah.
That's your start point, because it probably is.
Assume someone else is here, and you just don't know it.
Someone else is
It
here.
reminds me of the fun hotel game of when traveling and there were Cisco phones there, just plugging into the data port in the back of the phone and seeing if they had it misconfigured to get you landed on the data VLAN as well as
Right.
off the back of the phone there. It's like, fun times.
I also think
People
that
never
on
know.
the insider threat issue, and Al, you can talk to this because you did this for years, you never have a single point of authorization, right? So if you look at, everyone loves to talk about like the nuclear codes, right? But there's many other examples of this where you have to have multiple people authorize something. And we really need that in DevOps because like the Lapsus, you have an insider, but if their manager has to sign off on something, it gives an extra layer of protection there, right? Where, okay, why are you at like midnight wanting to open up some ports in the network?
Yeah, just another set of eyeballs to look at it,
And Al, I know that was sort of like some of the stuff you instilled in terms of like cyber defenses is no single point of failure. Maybe you can sort of talk a little.
Yeah, well, I do have some experience with nuclear weapons, so the counting on one person for something that's critical is never really a good idea. So if you can create a two-key system, for example, for some of your software builds where there's or network access that are critical, then that's obviously the right answer. Those most critical either software builds or those most critical access needs, elevated privileges, they all should have multiple requirements. It shouldn't be a one and done.
I mean, we have this in software today, although people break these rules all the time, right? We see this in open source where you're supposed to have multiple people do a review. But we've seen this, the nepotism problem sometimes where people have their buddy sitting next to them or whatever. Like this previous project we worked on may have had that happen a few times. Where somebody's buddy checks the thing in. He says, we have time pressure, get it in there, whatever. This is how these things happen. It's you pay me now, pay me later. Pay me now or pay me to the right of boom.
It's the old trade-off, right? It's always usability and security are always at odds. Like if you look at two-factor authentication, right? How many people have like a damn actual YubiKey second factor versus how many people are using the same software token built into their password manager for like all of the things? It's not a second factor; it's on the same device.
Right.
That's important.
But it's less usable.
We have to get off passwords. The passwords it's just, first of all, people use either the same password, a minor change off that password, or, the word password.
Yep. Yeah.
It's so dumb.
There's ways to do that too. So we got to get past it.
I mean, the other thing though about I guess the security practices and is when they can become a barrier to like business continuity. So let's say like you need that second approval to upload a change, right? And it's the middle of the night and the whole thing has gone down and the on-call people are like pulling their hair out because it's like, oh my God, we got to do this right now to get the whole business back up. And then they got to go and like, oh man, we got to go and find the guy that's not on call because he's the he's the like the boss is the one that needs to approve it, and it's like 4 a.m. and he's not going to appreciate getting that call.
But even when that happens, though, there have to be two people involved. That's the thing. Like, there should be no exception where there's an emergency where one person goes and pushes a lot of buttons. That's it's pay me now or pay me later.
Right. Yeah, I guess it's all right if you've got that size of team, right, where you can afford to have more than one person on call, dealing with these type of things.
Or some process where you have you have some kind of oversight, in the process. And this applies, to folks listening, not just to, proprietary commercial software, but also open source. I mean, as much as it does there, it does at open source as well. It's making changes to functional modules because of some emergency. We need to remember that these are mostly concocted by the people working on the projects, right? And it's artificial. What is the cost for waiting another week? The world's not going to come to an end if nobody gets an update to, whatever module you're working on.
Yeah. Yep. Well,
so just switching gears quickly before we wind up, Kyle. I know we're heading towards the end of time. Right. We talked a bit about preventative measures, and I know we've mentioned before on the show about doing things like scanning for CVEs and understanding your software bill of materials and other bits and pieces. But I guess Vinny, Al, is there anything else preventative, beyond the things that the typical network engineer with firewalls, IDS, IPS, or all of those type of things? What's new there in the preventative measures category of things that we should be paying attention to?
I think there's a lot of solutions that you can really take a look at the software that you're building that are available. I think we need to take a look at a broader automated ability to do that at scale. I think, as I think through the problem, at least in the development phase, there should be more tools available and automated that would help to make it easier not to be to the right of boom, but actually get to the left of boom. I think it's a doable issue, and just to remind everybody that this whole domain is man-made. So if we broke it, we can fix it. So don't give up hope and continue to strive to make it a better place to be.
I think that's really great.
Good approach.
Yeah, I like that kind of as almost closing words there too, Al. But before we wrap up, I'm told that there might be a story behind the picture there behind you, which might be interesting.
Oh, this?
Yeah.
Okay. So I did a little bit of time in the military. I was in Iraq the year that they took over Iraq and they freed the people there. As part of that, we tried to buy things off the local economy to get the economy going, because a war-torn country needs the economy to jumpstart. So there was a group of painters, kind of the top painters in Iraq, that wanted to sell their paintings. And so they brought it to our base camp in Baghdad. And this particular painting was being sold by a gentleman who was required to paint at gunpoint by Saddam Hussein and his henchmen. Wow. And this was the first painting that the guy got to paint of his own free will. So this is just whatever it is he wanted to paint. Wow. So to me, this represents freedom, and it's why I bought it. But it's just kind of a neat painting about the Middle East. Rug is a big buy, right? So this is right. This is a wealthy person here with all these guys that are giving him advice about this particular rug. there's rugs he didn't choose on the bottom, and these guys are just flipping and the next rug over top.
Oh, that's how they do it. They just flip it on the
Yeah,
wall and then they
that's
drop
right.
it if they don't want it. And oh, wow.
And then there's a shadowy figure right here that to me says, "I'm not sure I'm free yet." In this doorway here, so that's the story behind it. It's kind of the
I
quick
love it.
That's cool.
story behind it.
That is
Oh,
pretty
that's
neat.
really cool.
Thanks for sharing. That's
Yeah,
really great.
Yeah.
Thank
Well, this
you
was
for your
great.
Thank you
Yeah,
for your service, Al.
Yeah, thank you so much, Al.
No,
Definitely.
my pleasure.
Yeah, and this was
Thanks for the
great.
invitation.
Yeah, this was great. We're super excited that you both were able to come on and chat with us as well. This has really been great. To all of our listeners, stay tuned for our future episodes. We definitely want to thank our sponsor, T1 Nexus. We appreciate their support for helping us put this on. If you need SFPs, you know where to go. That's what Tom always says.
Nowhere to go.
So definitely. So thanks a lot, and we hope to see you all soon. Thanks.